Algebra 2 test review for Module 1, Properties of Functions. Question 1. Two functions are expressed in the tables. Complete the statement to compare the functions. And we're going to have two functions. And in this table, I'm going to label population as our f of x and the number of representatives as our g of x. Now, a quick review of one-to-one functions. For a one-to-one function, you have to have one x value has to be matched up with exactly one y value. And if I go in the other direction, one y value has to have exactly one x value. So if I have the population as my x's and we'll just do the x's will be our state, and then the y is going to be a population and our number of representatives. So if I just look at the population and the states, each state has exactly one unique population, so that is a function. Now if I go the other direction, the population to the state, each one of these populations has exactly one state matched up with it. So we would say that f of x is a one-to-one function. Now, if I look at the number of representatives, you'll notice that the number of representatives right here, 27, is mentioned twice. That can be okay for it to be a function, but if I were to go the opposite direction, so number of representatives to the state, it would not be a function because I have two 27s. I have 27 matched up with two different states. So a key here is to look at, do any of the numbers repeat? If any of the numbers repeat and they give you a different partner, then it's not one-to-one. So g of x is not a one-to-one function here. Question 2. Identify the maximum value of the domain in each of these functions. So the key phrase here is the domain. We're only looking at x values. So we're looking at the biggest x value. And the biggest x value is going to be to the farthest right. And since there's an endpoint right here, that is the last x value you can have. And so if I go straight up to the x axis, it'll tell me that the biggest x value is 3. Same thing with g of x. I go to the far right, and the farthest right I have, where there's a point, would be at 6. Question 3. Identify each function as linear or nonlinear. Remember, linear can be written as y equals mx plus b, or in standard form of ax plus by equals c. And nonlinear, those are ones that have they have an exponent greater than 1, or you're dividing by x, or you might have where there's multiple variables multiplied by each other. So if I look at letter A, h of x equaling x plus 11 divided by 8. Now this one is actually in y equals mx plus b format, because if I were to rewrite this, this is really saying 1/8 x plus 11/8. So that would be, my slope is 1/8 and my y-intercept is 11/8. So this would be linear. Letter B, y equals negative 3xy plus 16. Because I have this x times y, I would have to get the y's all together, but then I would have to factor out a y, and then my final step would be to divide by x. So what I mean by that is I would just get this plus 3xy to the other side. I'm going to put that down here. So now I have y plus 3xy equals 16. I would factor out a y, and I would have 1 plus 3x equaling 16. And to get the y by itself, I would divide by 1 plus 3x. And I would have an equation of y equals 16 divided by 1 plus 3x. And because my x is in the denominator of a function, of the denominator, that means it's going to be nonlinear. And letter C, f of x equaling 1/7. This is a constant. It's always going to be, y is always going to be 1/7. So this would be a horizontal line. So this would be linear. Question 4. Identify the type of symmetry for each graph. Line, point, or no symmetry. Now this first one has a unique shape. It looks kind of awkward. There's nothing that is the same about it. So this would be no symmetry. The upper right hand one here, you can treat this, that one's almost like a spinner, because if I spun it around this point, and this line here is going to match up with this part, and this part's going to match up with this one if I were to rotate it 180 degrees. So since I could rotate this around that point or 180 degrees, this would be point symmetry. On the last one, this has a pattern in our shape. So if I were to draw a line straight through the center of the vertex of this parabola, the left side is going to match the right side. Anytime that happens, when you draw a vertical line and it's a mirror image on each side, that would be line symmetry. Question 5. Describe the end behavior of each function. So for f of x up here, I would start off with, actually before I write the statements, let's put our infinities in. So this is positive infinity, this is negative infinity, this is negative infinity, and this is positive infinity. So now our two statements. As x approaches negative infinity, so when I go to the left here, the arrowhead is pointing up to positive infinity. So you can either say y or f of x. I'll just use y here. So y approaches positive infinity. And the second statement, as x approaches positive infinity, so when I go to the right here, the arrow is pointing down here. So we would say that y approaches negative infinity. Next, do the same thing. Here's positive infinity, negative infinity, positive infinity, and negative infinity. We start off with our same statements. So as x approaches negative infinity, y approaches, so when I go to the right, to the left, where is the arrow pointing? Since this is going right to the right, or right to the left here, it's not approaching positive or negative infinity. It's always the same number. And if I look at the y-axis, it's always going to equal 2. So instead of approaching, I'm going to use the equal sign. Y is going to equal 2. Second statement, as x approaches positive infinity, so when I go to the right, it's still, y still equals a positive 2. Question 6, compare the extremas of both functions. So here, we're just going to identify the extrema and then compare from there. So right here, I do have a relative max. Because it's a high point, it's just not the highest point. And we would say the relative max, the ordered pair would be 0, that'd be 1, 2, 3, 4. And it has a relative minimum here. and that would be at 2, 0. And the other function, here I have a relative max there. And this would be at 0, 0, or the origin. And I have 2 minimums because they are the lowest points. And the 2 minimums, we have -1, -1, and we have 1, -1. Question 7. Use the description in the graph to compare the 2 functions, and then which function has a lesser minimum. So what I would do in this one is I would take the description and I want to plot the minimum on there because I already have a graph for g of x. So if I go to the relative minimum here, they said it's relative at -0.4 and 1.1. So that would be roughly here. That would be like the lowest point in that function, so f of x. And here's where g of x is. They have a minimum here. So we would consider g of x as the lesser minimum. Question 8. What is the minimum value of the function? So we have an absolute value function, and the minimum value is going to be the vertex. Now, when you think about absolute value, the main format is this: f of x equaling a times the absolute value of x minus h plus k. We want to identify the vertex, and the vertex is whatever h and k is. Now, since I have a plus sign right here, that's really saying x minus a -7 in the absolute value here. And then I have this -3. So that means my h is going to be at -7, or my x is going to be at -7. My k is my y value of my vertex, which will be a -3. So the minimum value would be -7, -3. Question 9. Write the equation of the function f of x shown in the graph. So this is an absolute value. So I'm going to use the same equation I have in question 8. But I'm going to plug in numbers in for the variables. So I need my vertex first, which is right here. So that's 3, -2. So I'm going to put that in for my h and my k. So my h is 3, so that's going to be a -3. My k, it went down 2, so that's a -2. And then I need an x and y coordinate so I can find my a. And I'm going to choose this point right here because I know the coordinates of that one. There are other ones you could use, but I'm just going to use this one because it's a little bit easier. So my x is 2. I need to find my a when my y is 0. So now I can simplify what I have here. 2 minus 1 is negative, or 2 minus 3 is -1. The absolute value of -1 is 1. 1 times a is a. And then I have a -2 equals 0. To get a by itself, I'm going to add 2 to both sides. That means a is going to equal 2. So my function, so if I label this, well, this would be f of x. So if I have f of x equaling my a, which is 2, times the absolute value of x minus 3 minus 2. Now I can check this quickly by putting in another point in for x. So let's just say I put this point in there. So if I put a 4 in for x, my y should be 0. So 4 minus 3 is 1. The absolute value of 1 is 1. 1 times 2 is 2. 2 minus 2 is 0. So I know that my function that I just wrote, it matches up with the the graph that is plotted here. Question 10. Identify the reflection in each function as it relates to the graph of its parent function. So we're going to either determine if it's reflected over the x-axis or the y-axis. So if it's reflected over the x-axis, the y-coordinate is affected. If it's across the y-axis, the x-coordinate is affected by the negative. So m of x equaling negative 3x squared. Now the negative is on the inside. So the negative, I'm multiplying the x by the negative, so my x is affected by the negative before I square it. So since the x-coordinate is affected, it's going to be across the y-axis. J of x equaling negative times the absolute value of 5x. Now the x on the inside does not have a negative, so it's not affected. The last step that I would do to solve this one would be to multiply by a negative. So my y-coordinate is affected by the negative. So if my y-coordinate is affected, it's across the x-axis. And f of x equaling negative 3 times the absolute value of x minus 5. Because the negative is on the outside of my absolute value, my y-coordinate is affected, and because my y-coordinate is affected, it's reflected over the x-axis. Question 11. Selena is planning a birthday party for her little sister at a local zoo. The price depends on the number of children that attend the party. The price per child is normally $6. However, if there are more than 12 children in a group, the group can pay a $30 fee plus $2 per child. Write a piecewise function that best models the cost of the party C of x if Selena invites x children. And how much would it cost 22 children? So the first thing I'm going to do is create my piecewise function. And we're going to use C of x because that's what they're giving us. So we would have C of x equals, and then we have our piecewise function. So the first part says the price per child is normally $6. So I'm going to have $6 here. If that means if x is less than 6, or not less than 6, if I go to the next one here where it says if there are more than 12. So if it's more than 12, you get a discount. So we're going to have when x is less than or equal to 12, but it has to be greater than 0. You're going to pay $6 per child. Now, if you have more than 12, you're going to have to pay $30 plus $2 per child. So that's 2x. If your x is greater than 12. Now we can use one of these functions to answer the question. How much would it cost 22 children? So 22 is our x. So I look at my domains and figure out where is 22 located. 22 is greater than 12, so I would have to use this function to solve. So I would have 30 plus 2 times 22. So 2 times 22 is 44. 44 plus 30 would give us $74. Question 12. Are the following functions even, odd, or neither? And then prove your choice by solving it algebraically. Now for me, I would just do the algebraic part first because that will tell us which kind of function would be. So to prove this one, or to check this one, you're going to put a negative x wherever you see a negative x. So I would have negative x, and it's important that you put that in parentheses with the exponent on the outside, minus 3 times negative x squared plus 4. Now if I simplify this one, negative x to the third power would still give us a negative x cubed. Negative x squared is x squared times a negative 3 would give us a negative 3x squared. And then I have a plus 4. Now if I look at the signs, so f of x in my new function, the x cubes changed signs, the x squared stayed the same, the 4 stayed the same. Since some of them changed, others did not, this would be considered neither. Next one, f of x equaling x to the fourth minus 2x squared. Again, I'm going to put the negative x in for x. And then simplify it. So this negative x to the fourth, negative x times negative x times negative x times negative x would also give us x to the fourth. And then negative x squared would be x squared times negative 2 would give us negative 2x squared. Since I compare it, I have my x to the fourth did not change signs, and my 2x squared did not change signs. So when there's no sign change at all, this would be even. So one way to think about it is even is equal. So if the two equations are identical, they're equal, so they are even. If all of the signs would change, that means it would be odd. Question 13. State the domain and range of the function in set builder and interval notation. So first in set builder notation, we would do the domain and we would start with braces and we would say x such as. And so I'm looking at my domain, all my x values. Since the arrows are going up and to the right and up and to the left, my domain would be all real. So I can do x is an element of real, or you could just say x is all real numbers. And then the range in set builder notation, the lowest point is at negative 2. So I would start off the same way as my brace, but this time I would use y such as y is going to be greater than or equal to negative 2. And then in interval notation, we're going to use parentheses or brackets or a combination of both. Since the domain is all real numbers, I'm going to be using infinity. Anytime you use infinity, you have to use parentheses. So on the low end, it's negative infinity, and on the high end, it's positive infinity. And they both end with parentheses. Just always put the smaller one on the left and the bigger number on the right. And the range in interval notation, since it's greater than or equal to negative 2, the lowest number is 2, negative 2. So since it can equal negative 2, I use bracket. And the arrows keep going on to positive infinity, so I would have positive infinity with parentheses. And our last question, question 14, determine the transformation in each function as it relates to the parent function f of x equaling x squared. And then we're going to write the function for each graph. Now this only has translations, so there's no dilation or reflection involved. So normally a parent function is at the origin and it's at these 3 points. So all we want to do is compare where did the vertex go. The vertex, so my y's are counting by 2's. So it went, so the vertex here is at negative 5, negative 3. So since it's at negative 5, negative 3, we would consider this one, I'm just going to label it as g of x equaling x plus 5 minus 3. So I just put the coordinates my coordinates of my vertex in there, it's a plus 5 because my x is a minus 5. Because remember, it's x minus h. And if I were to put x minus, and h is a negative number, there's my minus and negative, there's my plus 5. So this one, it went to the left 5, down 3. Next one, the vertex is right here. So this one, so g of x equaling, it went to the right 3, so that's a minus 3 inside here, and it went down 5, so minus 5. So this one would be right 3, down 5. Our next one, vertex is right here. This one went to the right 5, and it went down 3. So now I can write my equation. So g of x equals, and since it's to the right, it just be a minus 5, and then down 3 minus 3. And our last one, this one went to the left 3, down 5. And my equation, g of x equaling, since it's to the left, it's going to be a plus inside the parentheses, so a plus 3 squared, and then down 5 means minus 5. So those are questions you can use to review for Module 1.